Hello everybody, welcome back. Today we're going to be finishing off 5.7 as well as the chapter 5. We're looking at example 3. It says match a graph to a given rate of change in vertical intercept. It says which graph is a rate of change of 1/2 and a vertical intercept of 6. Justify your answer. So obviously they both have a vertical intercept of 6. A rate of change, a positive rate of change would actually increase from left to right. So it's obviously graph B, but I'm going to show you how to obtain that value using the formula that we've learned earlier in the section of the chapter. So rate of change, it's your change in your dependent over the change in your independent, or the change in y over the change in x, or the change in vertical over the change in horizontal, whatever you want to look at it. So rate of change, all you have to simply put is the change in d for distance, lower d, and over the change in t, lower t. So you can see that you're clearly going down 1. So the change in d from point to point, and it's consistent. So it's down 1, and we show that by, there's a couple ways to show it. I'll show it the way just so it'll work every time. So it's just final minus initial, or 1 point minus the next point. So if you're looking here, again, you can do this different ways. There's different approaches you could do to this, but I think you can clearly see that you're going down. And again, you go to the point, you can go from here to this point to this point. So this point here is d is 6, that is 0. So you go 0 minus 6. And we're going from 12, we started at 0, went to 12. So it's 12 minus 0. And that would equal, we insert our fraction, negative 6 over 12, which is equal to negative 1/2. Okay? So this obviously is why showing that why it's not A. Again, you can do the same thing with the B part, the rate of change. All right. We can look at it again. It's distance over time. This time, pick any 2 points. So we'll pick the first and the third point. It doesn't make a difference. So I go right minus left, or the final minus initial, whatever you want to look at it. So here we have 10 minus the initial distance of 6, and our time was 8 minus 0, right? 8.8 for time, and then we started at 0, 8 minus 0. So that would give us 4 over 8, which is equal to positive 1/2. And the answer's finished. So we want a little statement. So for the A part, right, this is not the correct graph, obviously, right? We showed that here with negative 1/2. And then B, so it is the correct graph, right? You can clearly see that. Has a rate of change, both at 6, so it can be B. So in the next example, what we're going to do is we're going to look at the cost here. So this is the cost of publishing a yearbook in Winnipeg. The budget is $4,200. What is the maximum of books that can be printed? So this shows a graph, a linear. Obviously, it's $500 for no yearbooks. That just means it's an upfront cost. You know, you got to make the yearbook, the time to put in to create it, and whatnot. So if you didn't sell any, it's still $500, and then it's increasing by a certain amount. So let's look at that. So the first method would be just to estimate the number of yearbooks that could be printed for $4,200. So it's pretty straight edge. Take a ruler, put it through all the points. Look at where it's roughly, you know, this dotted line shows roughly around $4,200. Come down. This would be 175, so I'd say 180, 185-ish. That would probably be roughly what it would represent. Yeah, so about 180. It could be printed. That's what they're showing. So the second method is to set up a cost. This is the cost when the number of books is 0. So you can clearly see that the number of books for 0 is 500. So that would be the y-intercept. And then you can see that it's increasing. What's the rate of change? So the rate of change of the function is it's going up by 1,000 for every 50 yearbooks sold. Okay? So here's a visual to go along with that. So for every 50 books, which are horizontal, costs an extra 1,000. So we just take the 1,000 and divide it by 50, and it's $20 a yearbook. I'll show that with the rate of change. So the graph shows that for every 50 yearbooks print, the cost increases by 1,000. So that rate of change is $20 per book. So the increase in cost for each additional book is $20. So that equation would be the cost is equal to 20 multiplied by the number of books, add the 500. So to determine the book, we can use an equation here. All right, and we can just use that equation. So take my cost, and cost is going to equal, we'll take the 20 and multiply it by 500, put the cost in at 4,200. So 4,200 is equal to 20N. Subtract the 500 from both sides. So when we subtract 500 from both sides, we get 3,700. And we divide each side by 20. And when we divide each side by 20, we get N is equal to 185. So our estimate was close in the previous example. Okay? So there's check your understanding to go with that question. And then we'll be looking at the homework, which is located on there, and there's a chapter review. So that's it for chapter 5. Thanks everybody, and we'll be in touch. And thanks for everything, and see you again soon.